Hi everyone again. We're just going to talk a little bit about different forms of quadratic equations again and learn a new one today. So the first thing is I just want to recall the two forms we've already learned. So the first one is standard form. You can see standard form up here. The most important thing is that you get the y-intercept from the c value that's kind of tacked on to the end of this equation. The other thing that you know is that the a value gives you important information about whether the graph opens up or down. That's whether it's positive or negative. It also gives you an idea about the shape and the step pattern that can help you make a really nice graph. We learned that when we have vertex form, the a value here also gives you the exact same information, but vertex form is a lot more useful for graphing because the h and the k value give you the vertex itself. Now just a quick example so we can highlight something important about this. Remember I said yesterday that this minus is incredibly important. So if we look at an example where we're just trying to find the vertex of a given parabola, so we have y equals, let's say, minus 2x plus 4 all squared minus 7, and we want to identify what the vertex is. Well, this positive is actually part of this equation. So minus 2x minus 4 all squared minus 7, because it has to be negative here if you're going to use vertex form to identify what the vertex is. So the vertex here is actually equal to minus 4 minus 7. And that's the most common mistakes that students make about identifying the vertex. One useful way to remember it is if it's in the bracket here, that's sort of the opposite of what you would expect. Better understanding is to think about it this way, that it actually comes from being minus a number that gave you that plus over here. Okay, but either way that you remember it, it'll be just fine. So we're going to look at a new form today. This new form is called factored forms. I'll write that right up at the top. Factored form. And we have y equals a. Now that's the same a we were dealing with before. So it still gives you the same information. Minus r times x minus s. Now notice if you have r equals 0 and s equals 0, then the equation is going to become y equals, this x minus 0 will just become x. This x minus 0 will just become x. So let's multiply those together, and you get a. So y equals ax squared. So what this tells us is that that x value there is still squared, and that means that we have a quadratic. So we still are talking about quadratics. Okay, so that's important that you just kind of see that this is actually an x squared and that the degree is 2, and we talked about if the degree is 2, then it is a parabola. So this is our new form. We're going to do a little investigation about it. We're going to take a look at it. So let's take a look in Desmos. So let's go to my Desmos app. Give it a second to boot up here. And so when we look at Desmos, I've put in that exact equation. So y equals a, x minus r, times x minus s. So I'll just open up that file. And so I've also overlaid on top of it just the standard parabola, the base function. And you notice here I've made r 0 and s 0, and we have that base function. So when r is 0 and s is 0 and a is 1, we just get that base function right out of there. Now, what I'm going to do is I'm just going to change the value of r. And we're going to take a look at what happens when we do that. So let's change the value of r up to about 4. Okay, so it's at 4.2. You see that we still have the graph intersecting the x-axis at 0 here, but now the graph also intersects somewhere out here as well. And so just so we can see that a little better, I'm going to turn on the line at y equals 0. If I can get that to work just right. There we go. And then it allows me to show you the intersection. So now you'll see that it's exactly at 4.2. So when I change this r value, let's go over here to negative 6. We can look for that intersection point right there. We can see, oh, we're at negative 5.8. Oh, I also have the x-intercept here at negative 5.8. Likewise, if I change s, what I'm able to do is I'm able to pull that graph off of x equals 0 out of that origin. I can go over here to 5, and you can see here that the intersection there is 5. So r and s look like they're giving us the x-intercepts. Now, will that stay true when we change the value of a? So as we change the value of a, yeah, you can see the graph, when we go negative, the vertex goes above the axis. And when we go below 1, you can see this graph is going to get wider and wider and wider. Okay? And when we go bigger than 0, it's positive and wide. And then we get above 1 and it starts to go narrow, more and more narrow. And so, yeah, it appears to hold that no matter what the value of a is, when r and s are something other than 0, then we get these two x-intercepts. And so let's just go back to our file and let's just summarize that. So our conclusion here is that the a value still gives us the same information. So the a value is still open up or down. And it also gives us compressed or stretched. But now we have this new information right here and here. This gives us the x-intercepts. Now that's pretty powerful, but we'll still have the same problem. If we think about a very simple graph, so I'll go down here and I'll make one. If I knew the x-intercepts here and here, and I didn't have any other information about the graph, I wouldn't be able to make a good graph. It could look like that, could look like this, could look like that. And so if we think about the information that we would need to have in order to make a nice graph, we really, really need that vertex. And so let's go think about this. How can we get this vertex? Well, in this example here, I've written out y equals -1 times x plus 3 times x minus 8. And if I want to think about where that vertex is, remember that these are symmetrical. So that vertex is going to fall right in between that -3 x-intercept and that positive 8 x-intercept. Now notice in the equation as well, we've got -8 here, but the x-intercept is +8. And that's for that exact same reason that we saw in vertex form. That, remember, the form of the equation is x minus r and x minus s. And so because of that, those signs look like they're switched, but they're really not, because it's -8 that would give us a positive. So it has to be -+8 to give us the negative here. Okay, so x minus 8 here gives us an x-intercept of +8, and the same thing here. X plus 3 gives us an intercept of -3 over here. Now, what we really need to do is we need to figure out where the middle is between those two things. And luckily, we have that tool already. Okay? We learned that in analytic geometry. When we're looking for the middle of things, we just use a midpoint. So when we're using midpoints, we just add the values up and we divide by 2. So -3 plus 8 is equal to -5, and -5 over 2, or +5 over 2, sorry, is equal to 2.5. And so that's the x value of the vertex. So we can write that in up here. So we've got 2.5 and whatever the y value of the vertex is. We don't know that yet. And so now if we go over here and we want to think about what the y value of the vertex is, remember the equation that defines all the y values on the parabola is -1 times x plus 3 times x minus 8. So we know the x value. The x value is 2.5, right? 2.5. So x, we know what x is. X is 2.5 minus 8. And then we're just going to simplify this. You can use a calculator for this. I'm going to use my fancy program here. So -1 times 2.5 plus 3 times 2.5 minus 8. And what do we get? We get 30.25. So that's going to be the y value of our vertex. So we go back here, and we'll just write that in. We get 30.25. And thus, the vertex is going to be 2.5 and 30.25. Okay? So now, what that allows us to do is make a really nice graph of this. So if we go back here, we have the vertex and we have the x-intercept. So I'm just going to draw a quick sketch of this one. We'll do a nice one in a second. So we have the x-intercept at minus 3, and the other x-intercept way out there at about 8. And then at 2.5, 30, and that's going to be way up high, right? So I'm going to draw this on like that. It's a pretty bad sketch, but that's okay. We're just trying to show this kind of in a rudimentary sense right now. So this is 2.5 and 30.25. And this is going to be minus 3, and that's plus 8. And you see how we have all the information to make a pretty nice sketch out of that. So let's take a look at another example. So the first thing you want to do when you're graphing a parabola is you want to take a look at it and identify the form. So in this case, we have factored form. So the features we can identify out of this is it opens up, because that a value is bigger than, that's a positive number. So it opens up. It's bigger than 0. Okay, and we also know that it's stretched by a factor of 2. Okay, stretched by a factor of 2, and it has x-intercepts of minus 4 from this one and plus 6 from that one. So minus 4 and plus 6. Minus 4 and plus 6. So from that, we should be able to determine what the vertex is. So we're going to determine the vertex now. The first thing we can do is we'll go over here just to get more space. The x value of the vertex is going to be minus 4 plus 6 over 2, which will be 2 over 2, which is equal to 1. Now we can take that and we can find the y value of the vertex. We use the original equation, which we were given at the top. So that's 2 times x plus 4 times x minus 6. And we just plug in that the x value of the vertex. So the y value of the vertex, 2 times 1 plus 4 times 1 plus or minus 6 is equal to be 2 times 5 times minus 5, okay, which is going to be minus, so take a look at this, 2 times 5 is 10, 10 times 5 is minus 50, okay? Now, does it make sense for that to be so low? Well, we know it opens up, it's very thin, but we're looking at x-intercepts that are pretty far apart, okay? So now we can use that information to graph. So let's go over here, got a little graph set up here. And now when we take a look, we've got x-intercepts of minus 4 and plus 6. So let's put those on 4 first. 1, 2, 3, 4. So that's at minus 4. 1, 2, 3, 4, 5, 6. Now another thing we know is the x equals 1 is going to be our axis of symmetry. That's where it's mirrored. So we'll just draw on an axis of symmetry at x equals 1. Just like that. And I'll write in what that is. It's going to be x equals 1. And then I'm going to have to make this go up by tens, I think. This is minus 10. It's minus 20. It's minus 30. It's minus 40. And it's minus 50. And right there is going to be our vertex. And you can see the symmetry already, right? So I'm going to put in the value there of 1 minus 50 as our vertex. And make sure that I show that this is plus 6 over here. And that's minus 4 over there. And then I'm going to draw kind of a nice smooth curve through those. I'll do the best I can with my tablet pen here. Not too bad, not too shabby at all. We'll just go with that. So we've got y equals, and we had 2 x plus 4 and x minus 6. And we've graphed a parabola using factored form now. So get on with your work, see what you can do. You should be able to tackle now 4.1 all the way over to 4.5. We'll wrap up the last section on Monday, and good luck to you.